Hello folks, welcome to our very first math lecture for the beginning of math class. In this lecture we are going to go over some basics with whole numbers. So no decimals, no fractions, that part comes later. Hopefully a lot of this is review or something that's jogging your memory from math classes many moons ago. If there are any topics in here that you feel you're very weak in, or you have questions about them, or you would like more help or more review, please get a hold of me. I have so much stuff that can help you with math. Math, just by virtue of what it is a topic that you master through endless repetition. So obviously do your homework. There are also some resources that I have linked to in the resources tab on Blackboard for math. Things like math TV videos and Khan Academy, which are both incredibly helpful for mastering some of these techniques. So with that said, let's take a look at our basics. As I mentioned before, a whole number is a number that does not have a fraction or a decimal. In the case of our three numbers here, we have 3 and 65 hundredths, 125, and 4 and 3/4. 125 is our whole number. There are no negative numbers in our career prep math class, which is really nice. You don't see a lot of negative numbers in medical math, with the exception of if you're involved in research projects or things like that. But in this class here, no negative numbers. So if you plug something into your calculator to check it and your answer comes back negative, go ahead and recheck it or do the problem over again because something went wrong somewhere. Place values are incredibly important to know when you are lining up your numbers, when you're doing rounding. This is something that I would start committing to memory. Hopefully you've seen something like this before. A note about our little commas here that separate our numbers. Remember that in American numerology, we use commas to separate every third number, and then a decimal when we have decimals towards the end. I know other countries you'll see decimals used and then a comma when you have your decimal towards the end. So just make sure that you pay attention to that if you've never seen that before. So place value indicates how much is a number worth in the position which it is in. Why is the 8 in $8 different than the 8 in $800? Why, if you owe $800 on your rent and you only give your landlord $8, will your landlord be cranky with you? We always start place value from the right. We go from right to left when we're doing place value. And the very first place value that we come across is the ones column right here. That's our 9. Next we have the tens and then the hundreds, and then a comma just to separate our numbers so they're a little easier to manage. And then after the comma will come everything in thousands. We have first thousands, then 10,000s, then 100,000s. And this pattern will repeat infinitely. After thousands, we get into millions. That's our next little set of 3 after that comma. So here we have millions, 10 millions, 100 millions. After millions, we have billions, and then of course 10 billions and 100 billions. After billions, we have trillions, and then 10 trillion and 100 trillion. After trillion, I think it's quadrillion. I'm not entirely certain. Whatever it is, the national debt is rapidly heading that way. Anyway, know your place values. Be able to take any number that I give you and pick a number in it and tell me what is the place value of that number. Now, rounding is particularly useful when we talk about, or place values are particularly useful when we talk about rounding numbers. Why do we round numbers? What is the point of this? Besides extra work for you to do on your homework. So rounding gives us a few benefits. It allows us to estimate answers. For example, if I have 593 plus 711, it's much easier to round these to, well, 593 is very close to 600 and 711 is very close to 700. Those are easier to add together, right? I have 0 plus 0, and then 6 plus 7 is 13. That's much simpler than sitting down and actually adding 593 plus 711. Other reasons why you might want to round, practically speaking, maybe you have to do something like go back and check supplies. And you want just an estimate of how much of everything you have. Maybe you want to give an estimated answer for how much a procedure might cost. There are so many reasons why you would want to be able to round numbers. It's particularly helpful, this example here, particularly helpful when you're trying to figure out what an answer should be close to. 600 plus 700 is close to 1300. Well, let's look at 593 plus 700 and see what our actual answer is. 593 times 711, 4, 10, carry our 1, 7 plus 5, 12 plus 1, 13. So 593 plus 711 is 1304, very close to 1300. So that's an example of the benefit of rounding in action. It gives you an answer that will be very close to what you're looking for without being precise. And there are some times when this will be very helpful. There are other times when it won't. If you want to check your answer on a problem, for example, this will be incredibly helpful. So let's talk about rounding. How do we round? And in my class, when we talk about this, we talk about a lovely couple, Bob and his girlfriend Felicia. And we talk about Bob because that's the name of the skeleton in my classroom. Unfortunately, you guys have not had the chance to meet Bob yet. So let's say we have 4,627 and we want to round it to the nearest tens place. First, we need to know what number's in the tens place. And this, like I said, is why you absolutely need to be comfortable with your place values and your numbers. So what number is in the tens place in 4,627? Remember, we go right to left. So the 7 is in the what place value? 7 should be in the ones place. 2 is in the tens place. 6 is in the hundreds. 4 is in the thousands place. Okay, so we're rounding to the nearest tens place. Our 2 is in the tens place. Essentially, what we're asking here is if we put this on a number line. Here is 4,620. Here is 4,630. Right here in the middle is 4,625, right in between the two of them. And we want to know 4,627, is it closer to 4,620 or is it closer to 4,630? Well, 27 would be right about here, give or take. So 4,627 is closer to 4,630. That is basically what we're looking at when we say we're rounding to the nearest tens place. Let's look practically now at what we do to figure that out. Go back and revisit our lovely couple, Bob and Felicia. They're having a lot of fun together in quarantine. So the number that's directly to the right of our 2 determines how we round. So our 2 right here, that's Bob. Meet Bob. The number that's directly to the right of Bob, the 7, is the number that determines what's going on, that tells Bob what to do. That's Felicia. They're a sweet couple. Felicia's going to tell Bob what to do. She's going to tell him if he's going to go up or stay the same. If Felicia is 5 or greater, then Bob's going to go up. By number, I mean Bob. If Felicia is less than 5, Bob is going to stay the same. So in the case of our 4,627 here, the number next to the 2 is greater than 5. Our number to the right of the 2, there's Felicia, is 7. And because that is greater than 5, Bob, our 2, is going to round up to a 3. And then everything to the right of that 2 is going to become a 0 because Bob is tired of Felicia telling him what to do. So she kicks him out. He kicks her out. She has to go sleep on her best friend's couch for a while. So our answer becomes 4,630. Right, the 7 here, the number to the right of our number to which we're rounding, determines whether or not the number we're rounding goes up or stays the same. I know a lot of the time you hear people talk about a number rounding up or rounding down. I don't really like that wording because it implies that our 2 would at one time go down. And that will never happen. So for example, let's say we have 4,624 instead of 27. And we want to round to the nearest 10. So again, here's Bob. Bob's our 2. And Felicia, who's always at his right, is going to tell him what to do. Now, since she is less than 5, Bob's going to stay the same. He's not going to change. So our number is going to round to 4,600. We keep the 2. And then again, Felicia gets kicked out because Bob's tired of dealing with her shenanigans. So your number to the right of whatever you're rounding to, in this case we're rounding to the tens place, everything to the right of that will always become 0. You should always have zeros towards the end of your number after you're rounding. Let's look at another example. So here we're going to round 5,327 to the nearest hundreds place. So take a minute before we even look at rounding and try and figure out what is the place value of each of these numbers. Right? 7 is in the what place, 2 is in the what place, 3 and 5 and so on. So which number here is in the hundreds place? Should be 3. There's Bob. And of course, Felicia is always right to the right of him, so Felicia is our 2 right there. So 3 is in the hundreds place. 2 is directly to the right of our 3. There's Felicia. And she's going to tell Bob what to do. She's always the one who makes that decision. They're in couples therapy. They're having a rough time. Because that 2 is less than 5, Bob is not going to change. He's going to stay the same. He's going to stay a 3. But then remember, he is tired of dealing with her nonsense, so he kicks Felicia out. So then everything to the right of Bob becomes a 0. If you're rounding properly, your number should always end in 0. So 5,327 rounds to 5,300. Again, if the number line helps you at all, what we're just saying is we have 5,300 and 5,400. Here is 5,350. And we want to know, is 5,327, is it closer to 5,300 or is it closer to 5,400? Well, 5,327 is like right about there. So it is closer to 5,300 than it is to 5,400. Again, remember everything that is to the right of your number to which you're rounding to, everything that's to the right of Bob will become a 0. Felicia, all her stuff get kicked out. She has to go stay at her parents' place for a while. Fare thee well, Felicia. Okay, moving on. We are going to look at our 4 basic functions, adding, subtracting, multiplying, and dividing. And then we are going to wrap all those up together in PEMDAS, order of operations, which is usually the one thing that my students remember about the high school or middle school math, and usually they're very happy to roll off that acronym. Probably you're saying it right now. Please excuse my dear Aunt Sally. We are going to take a look at that after we go through our 4 basic functions. All right, let's take a look first at addition and subtraction because these are very, very similar, and you'll see a lot of overlap here. Your big reminder whenever we're doing any addition or subtraction, this guy right here, line your numbers up based on their place value. Every time you don't line your numbers up properly, I don't know, Satan kills a puppy. That's your number one concern with addition and subtraction. So you see over here our pretty example where the ones column is lined up, the tens column is lined up, the hundreds column is lined up. I often get a lot of this. Why is this wrong? This should make you kind of twitchy and very uncomfortable. Why? Why is this wrong? Because what place value is our 7 in here? The 7 in 781. This is in the hundreds place, but what is it lined up with? What is this 1 here? This guy's in the thousands place. Such a thing should not be. So do not do this. Make sure your ones column is lined up properly like that. Don't be responsible for the death of a puppy. When you are adding, make sure that when you're carrying, you're writing in the numbers that you carry. Don't do this in your head. You have so much more important stuff that you need to worry about in your head. Write stuff down. Be your own best friend. So for example, let's take a look at our good problem, not at the puppy killing one at the bottom. So 1,456 plus 781. Start on the right. Always start on the right in your ones column. 6 plus 1 is 7. 8 plus 5 is 13. Write down your 3, carry your 1. And then add that row up. 1 plus 4 is 5. 5 plus 7 is 12. Write down the 2, carry the 1. 1 plus 1 is 2. Done and done. So your answer is 2,237. If you are not certain, you can always plug it into a calculator and double check. Now, let's say it's the zombie apocalypse and your calculator was destroyed by a rampaging zombie. How on earth do you check your addition problem and know if you got it right? You subtract one of your add-ins. These two numbers here are add-ins from the sum. The sum is your answer. And you should get the other add-in. So we should be able to do 2,237 minus 781 and get 1,456. If you don't believe me, go ahead, plug it into your phone, because I'm sure your phone is right next to you right now, and you should get that for your answer. This is how we double check an addition problem, because addition is the opposite of subtraction. Always, always, always make sure you are double checking your work. I mean, right now you should be double checking your work because it could cost you your grade. In the future, you need to be double checking your work because it could cost you a patient, and nobody wants that. So make sure that you're always going back and looking over what you do a second time. Okay, how about subtraction? Again, make sure that you line up your numbers based on their place value. In addition, it didn't matter which number was on top or which one was on the bottom. In addition, both 24 plus 153 and 153 plus 24 were both legitimate problems. Both of them are going to get you 177. This is not the case in subtraction. The number that's worth more should always be on the top. So we see here 5,278 minus 521. If we were to flip these and put 521 on top and 5,278 on the bottom, your answer is going to be negative. And like I said before, we don't have any negatives in this class, so make sure that you are lining up your numbers properly. Like addition, when you are borrowing, make sure that you are writing that down. And to check your answer, you will add your answer to the smaller of your two subtractants in the problem. So let's take a look at an example, and then we'll talk about checking your problem. So over here, our properly set up problem. We have 5,278 minus 521. Again, always start on the right, so 8 minus 1 is 7. 7 minus 2 is 5. And now we have 2 minus 5. We can't do 2 minus 5 because 5 is greater than 2. If you have $2, I can't take $5 away from you. So in order to complete this, we're going to have to come over here, borrow from the 5, turn it into a 4, bring our 1 over here, and turn our 2 into 12. Now we can subtract that. 12 minus 5 will give us 7. And then we have 4 minus nothing out here, which is just 4. So our final answer is 4,757. Now, how do we check this? We take our 4,757, we add 521, and that should give us 5,278. Again, grab your phone, pull out your calculator app, and check it and see what you get. That should be your answer. And again, as always, make sure that you are double checking every problem as you go. Here's another example that I want to take a look at because problems like these usually throw my students for a loop when they're doing them by hand. So here we have 201,003 minus 54,255, a seemingly innocuous problem. So let's start over here on the right, like you should, 3 minus 4. Well, we can't do 3 minus 4. So we're going to borrow, but what are we going to borrow from? Can we borrow from 0? Turn them into -1. We can't borrow from the 0 in the tens column. We can't even borrow from the 0 in the hundreds column. We have to come all the way over here and borrow from that 1. Turn him into a 0. And now this is where a lot of my students get trigger happy. They borrow from the 1 and they say, okay, we borrowed from the 1, now he's 13, done. That's not how this works. That's not how any of this works. Once we borrow from the 1, we have to carry that number back across both of these zeros to the 3. Both of these zeros here, they want a piece of the pie and they're going to get it. So our 1 becomes a 0. And that 1, we move over here to our first 0 to become a 10. Now we're going to borrow from our 10, turn him into a 9, and put that 1 over here with our next 0. Now we're going to borrow from our 10, turn him into a 9, and bring that 1 over here to our 13. So we should end with 13, but both of these zeros here should become 9s by the time we're done. This is getting a little messy. Hopefully this makes sense. We cannot just borrow from our 1, turn him into a 0, turn the 3 into a 13, and call it good. We have to make sure that we go hit both of our numbers, both of our zeros on the way back. But now that we have 13 here instead of 3, now we can actually subtract. So 13 minus 4 should give us 9. Then we have 9 minus 5, which is 4, 9 minus 2, which is 7. Here we have 0 and 4. And this is another place where I see a lot of pitfalls with my students. A lot of them look at this and say, well, 0 is nothing, 4 minus 0 is 4. But what we're asking here in this part of the problem is, what is 0 take away 4? If you have $0, can I take 4 of them away? No, I cannot. So in order to fulfill this part of the problem, we're going to have to borrow again. And again, we find a 0 right next to us as our neighbor. We cannot borrow from that 0, so we're going to have to skip over him and go all the way over here to the 2. Borrow from the 2, he becomes a 1. And then, just like we had to go back one step at a time from our 1 to our 3 over here, we have to do the same thing here. We borrowed from the 2 and made him a 1. Our 0 becomes a 10. Then we borrow from that 10, it becomes a 9, and our 0 here becomes a 10. So again, when you're borrowing in between numbers, you cannot skip over the numbers in the middle. You have to make sure everybody gets some of the action. Okay, now we have 10 minus 4. That we can do. 10 minus 4 is 6. And then our 0 has become a 9, so 9 minus 5, which is 4. Our 2 became a 1 over here, and we have 1 minus nothing, which is 1. So 201,003 minus 54,254 should give us 146,749. And again, if you plug this into your calculator, or if you really like math, if you do it by hand, plus 54 to 54, you should get 201,003. Always check your work. I am assuming that you guys are all doing your homework on calculators, and I don't care because I can't stop you, but I do really recommend that you at least try. Push yourself a little bit and try these problems by hand before you just plug them into the calculator and call it good. All right, let's look now at multiplication. For multiplication, just like adding, just like subtracting, you want to make sure that your place values are lined up nice and neat. So like we see over here on the left, 6 is in the ones column, 4 is in the ones column, so they're lined up with each other properly. And when we're doing multiplication, you should always have the longer number on top versus the shorter number on top. The longer number on top will give you fewer rows that you have to multiply. And we'll look at that in a minute. But this is what you want, this is not. And we'll see why. So let's look at our multiplication problem over there on the left. 476 times 34. So when we multiply, we always want to start with the very first number on the right, whatever's in our ones place. In this case, it's that 4 right there. So we'll start by saying 4 times 6 times the number right above it. 4 times 6 is 24. We'll write down the number in the ones place, which is the 4, and carry the 2 in the tens place. And then we'll do across here, 4 times 7. 4 times 7 is 28. We'll add that 2. 28 plus 2 is 30. Write down the 0. Carry the 3. And then we'll keep going. 4 times 4 now. 4 times 4 is 16. 16 plus 3 is 19. And because there's nothing to carry to over on the left, we're just going to write down that 19. So far, so good. And you'll notice that I wrote down each number that I carried. Just like I said, in adding and subtracting, you want to write down when you're carrying for borrowing. You want to do the same thing in multiplication. Don't try to do this in your head. You've got way too much that's already bouncing around in there. Okay, so we did our first row. We multiplied by that 4. Let's take a look at our 3. Now we got to multiply by him. And before we start multiplying by the 3, we want to make sure that whatever we start multiplying lines up. Our first number lines up in the tens place under that 3. So in order to ensure that, we're going to start by putting a 0 under our ones column. This way, the first number that we write down is going to show up in that tens column. So put your 0 when you start your next row, and then we'll start with our 3. 3 times 6 is 18. Write down the 8, carry the 1. 3 times 7 is 21. 21 plus 1 is 22. So we'll write down the 2, carry the next 2. 3 times 4 is 12. 12 plus 2 is 14. And there's nothing to carry after that 4, so we just write the whole number down. Keeping your numbers nice and neat and organized is paramount to getting any kind of math right, but especially something like multiplication where you can wind up with a lot of rows. If you are doing stuff by hand and if you're having trouble keeping your numbers lined up, if you have just lined paper, turn your lined paper sideways and use those lines as columns to organize your numbers. Or you can get graph paper as well. That can be very, very useful for keeping your numbers lined up. Okay, now that we have our 2 rows multiplied, we're going to add these suckers together. So 4 plus 0 is 4, 0 plus 8 is 8, 9 plus 2 is 11, carry your 1, 1 plus 1 plus 4 is 6, and then our 1. So our final answer is 16,184. Probably the best thing that you can do for yourself right now is to spend some time, devote like 10 or 15 minutes a day to working on memorizing your multiplication tables. Yes, I know you have a calculator, and will probably always have a calculator at your disposal, but knowing your multiplication tables, being familiar with them, is going to serve you so well as you're working through math. So let's look at why our problem on the left is better for us, easier for us, than the problem on the right over here. Because we have the same 2 numbers, 34 times 476, and our properties of multiplication tell us that the answer is going to be the same, however we line up our 2 numbers. But when we do our longer number on the bottom, we wind up with more rows and more potential for error. So let's start in our ones column with our 6 right here. 6 times 4 is 24. Write down your 4, carry your 2. 6 times 3 is 18, plus the 2 is 20. 0, and write down the 2 because there's nothing to the left of the 3 to carry that 2. Okay, there's row number 1. Let's do row number 2. Now we're going to start with our 7. And just like in the other problem, when you start your next row, you add a 0 to make sure that the first number lines up in the tens column where the 7 is. Okay, 7 times 4 is 28. Write down your 8, carry your 2. 7 times 3 is 21. 21 plus 2 is 23. And again, there's nothing to carry that over, so we'll write the whole number. All right, last row. This is getting long. Now we're going to do the 4. And now, because when we started the row with the 7, we wanted our first number to line up with the 7. Now that we're starting our row with the 4, we want our first number to line up in the hundreds place where the 4 is. So now we're going to add 2 zeros so that our first number lines up with that 4. So here we're going to do 4 times 4, which is 16. Carry our 1. And then 4 times 3, which is 12. 12 plus 1 is 13. Now we add this monstrosity. So we get 4 plus 0 and 0 is 4. 0 plus 8 plus 0 is 8. 2 plus 3 is 5. 5 plus 6 is 11. Carry your 1. 1 plus 2 is 3. 3 plus 3 is 6. And then our 1 out here hanging out by his lonesome. So either way we get 16,184, but in this case here we had 3 rows, whereas in this one over here we only had 2. So hopefully that makes sense why this would be your preferred setup for the problem as opposed to the one on the right. All right, let's look at another example. 425 times 84. So as I said before, we're going to start on the right, go from the right to the left. So our first number that we have here is our 4. 4 times 5 is 20. Write the 0, carry the 2 in the tens place. Over to the next number. 4 times 2 now is 8. 8 plus 2 is 10. Write down your 0, carry the 1 in the tens column, and now 4 times 4. 4 times 4 is 16. 16 plus 1 is 17. First column done. Now let's do our 8. And remember, because we want the first number in this part of the multiplication to line up under the 8, we always start with a 0. So our first number is right in that tens place. All right, 8 times 5 is 40. Write down the 0, carry the 4 over to the next number. 8 times 2 is 16, plus the 4 is 20. Write down our 0, carry our 2. And then 8 times 4 is 32. 32 plus 2 gives us 34. Now that we're done with our multiplying, add everything together. So we get 0, 0, 7, 5, and 3. So 425 times 84 is 35,700. Let's look at one more example of long multiplication, and then we will move into division, and then after that we will take a look at PEMDAS. So here we have 3,426 times 53. Everything is lined up nice and neat and pretty, just like you want to see. And we will start on the right-hand side in our ones column with the 3. We'll start with 3 times 6, and 3 times 6 is 18. Write down the 8, and carry the 1. And then 3 times 2, which is 6, plus 1 is 7. 3 times 4 is 12. Write down the 2, carry the 1. And then 3 times 3 is 9. 9 plus 1 is 10. And since there's nowhere to carry, we'll just write down the whole 10. All right, so we got our 3. Now let's move on to the 5. And remember, when we start that second row of numbers, we're going to start always with a 0 first, so that our first number will line up right under the 5. So we'll start with 5 times 6. 5 times 6 is 30. We'll write down the 0 and carry the 3. 5 times 2 is 10. 10 plus 3 is 13. Write down the 3 and carry the 1. And then 5 times 4 is 20. 20 plus 1 is 21. So we'll write down the 1, carry the 2. And then 5 times 3 is 15. 15 plus 2 is 17. And there we go. And hopefully you've noticed I've been crossing out the carried numbers from our previous row as I go. That is particularly important because I see a lot of students who either don't cross them out or erase them and get thrown off when they have extra numbers up there and don't remember where they came from. So keeping your work nice and neat is paramount to good math in any topic. Okay, so now let's add our two rows together. 8 plus 0 is 8. 7 plus 0 is 7. 2 plus 3 is 5. 0 plus 1 is 1. 1 plus 7 is 8. And then our 1 all by his lonesome is just 1. So our answer is 181,578. All right, let's look at division. We will use division in different ways and in different topics as we go through math. Right now, because we're dealing in whole numbers, the smaller number on a division problem should always go on the outside of the division box. And yes, I know for those of you who recognize it, that's a square root box instead of division. PowerPoint doesn't let me do an actual division box, so don't at me. So we have here 492 divided by 12. The little number on the outside, this is the divisor. The number on the inside, this is the dividend. Divisor should always be smaller, dividend should always be bigger, at least for right now when we're dealing with whole numbers. When we start using division for various purposes in fractions and decimals, then that might look different. So 12 into 492. We start by taking our whole 12 and asking, will 12 go into 4? Can we divide 12 into 4? No, we can't, because 4 is smaller than 12. And if I have 12 people and I only have 4 cookies, can each person get a whole cookie? No, they can't. Okay, so 12 won't go into 4 because 4 is too small. Let's go one step out and say, can 12 go into 49? And 12 can go into 49 because 49 is greater than or equal to 12. So that's our first step. So now we will divide 12 into 49. So 12 times what gets us as close as possible to 49? Well, 12 times 4 is 48, and that's as close as we can get to 49 without going over. So 12 times 4 is 48. We will write the 4 above the 9. Again, keeping your numbers organized is very, very important. 4 times 12 is 48. Write the 48 below the 49 and subtract. 9 minus 8 is 1. And this answer here should be smaller than our divisor. If it is, that means that we did the division problem correctly and we put 4 into 49 as many times as it would go. If our answer is bigger than the divisor, then that means you did not put 4 into 49 as many times as possible. So now that we've finished our subtraction, our next step is going to be to bring down the next number directly to the right, which is a 2 in this case. So we bring down that 2 to get 12, and now we have 12 into 12. What is 12 divided by 12? Well, that's 1. Any number divided by itself is 1. 1 times 12 is 12. Write that underneath the 12 and subtract. Our answer is 0. We don't have any numbers over here that we need to bring down, so our final answer is 41. To double check our division problem, aside from plugging it into your calculator, you would set this up to multiply and check your answer. 2 times 1 is 2, 2 times 4 is 8, 1 times 1 and 1 times 4. Add the 2 together. You should get 492. Let's look at another example. Here we have 391 divided by 7, a little bit smaller divisor on the outside. We'll start with asking, does 7 go into 3? And the answer to that is no, because 3 is not equal to or greater than 7. Okay, so if it won't go into 3, how about 39? Will 7 go into 39? And the answer there is yes, because 39 is greater than or equal to 7. Okay, so how many times does 7 go into 39? 7 times what is very close to 39? And again, this is where knowing your multiplication table is going to put you leaps and bounds above anybody else. So 7 goes into 39 5 times, because 5 times 7 is 35, and that's as close as we can get to 39 without going over the number. So 5 times 7 is 35. We write the 35 under the 39, and you notice I put my answer, the 5, over the 9, because I'm indicating that we're putting 7 into 39 5 times. If I wrote the 5 here over the 3, that would be saying that 7 goes into 3 5 times. So again, being organized is of paramount importance in math. All right, 39 minus 35. 9 minus 5 is 4. 3 minus 3 is 0. So we're done. Next step is to bring down the 1. And now we have 7 into 41. So how many times will 7 go into 41 without going over? Well, 7 times 5 was 35. So what about 7 times 6? 7 times 6 is 42. So we're going to use 5 again, because if we use 6, we'll go over. So 5 times 7 is 35. Write that under the 41 and subtract. We'll have to borrow from our 4, turn our 5 into 11. That's 6. Okay, no more numbers over here that we bring down. There's nothing left here. We're just left with this 6 hanging out there with nothing to do with it. He is going to become our remainder. So our answer here is 55, remainder 6. And I want to see remainders in your answers when you're entering them on Blackboard so that I know that you're doing this properly. Right? I do not want decimals as an answer. I don't want to see 391.789. Make sure that you're giving me a remainder right now because we're dealing in whole numbers, not decimals. Okay, here we have 583 divided by 11. So first step, again, will 11 go into 5? No, it won't because 11 is greater than 5. Okay, let's look 2 over and say, will 11 go into 58? And it will. 11 will go into 58 5 times. So we'll write our 5 above the 8, and 11 times 5 is 55. Write that underneath the 58 and subtract. 58 minus 55 will give us 3. Right, done there. So let's bring down our next number. And now will 11 go into 33? And it will. 11 will go into 33 3 times. 3 times 11 is 33. And subtract. There we go. No remainder here with our 0. Nothing to bring down here. So we are done. 11 goes into 583 53 times. Right, now that we have visited all of our 4 basic functions, let's look at putting them together in order of operations. Probably you guys remember, most of you, PEMDAS. Please excuse my dear Aunt Sally from, I don't know, 5th, 6th grade math many, many moons ago. PEMDAS is what tells us if you have a problem like this, which part of that problem are you supposed to do first? And don't try to do this problem because I made it up off the top of my head and probably it's not going to come out with a nice answer. PEMDAS tells us if we've got a bunch of functions in a row, what do we do first? And we follow the order of operations that we have here to tell us what to do. So first step with PEMDAS, you do everything in parentheses first. Sometimes you'll see in our problems we'll have brackets and then parentheses and then a bracket. The bracket is a glorified parentheses. You would start with the parentheses inside the parentheses first. So we would do 2 minus 1 is 3. And then we would finish the bracket. So occasionally you'll see that. But everything that's within parentheses you'll do first. And then after that, once you've cleared out your parentheses, you will first do multiplication and division. This is the my dear in Please Excuse My Dear Aunt Sally. So you'll multiply and divide going left to right, whichever one comes first. I know that the order of operations is multiply, divide. That doesn't necessarily mean that that's how you do whatever you find. You just want to start with what's available. So if you have a division problem first, going left to right, you'll do that first. After you've done all of your multiplication and division, then you'll finish it up with addition and subtraction, also going left to right, whichever problem shows up first. So here is a nice example of our order of operations. We have 17 minus 6 divided by 2, all in parentheses, plus 4 times 3. Where do we start? Well, we start with our parentheses, everything that's within them, but we have 17 minus 6 and then we have 6 divided by 2. Which of these do we do first? Well, when we're inside the parentheses, our MDOS in our PEMDAS guides us to tell us what we do first. So the first thing we'll do is any multiplication or division. In this case, we have division. We have 6 divided by 2. So 17 minus, and what is 6 divided by 2? That's 3. Close our parentheses, plus 4 times 3. As you're working through an order of operations problem, make sure that for each step you complete, you just copy down the problem with that completed step in it. Don't try to skip steps. Don't try to do it in your head. Definitely don't try to do the whole thing at once. Just write down each new completed step after the last one. Okay, we still have parentheses though. We have 17 minus 3. So let's finish that out with our parentheses. 17 minus 3 is 14. So now we have 14 plus 4 times 3. Okay, next step. Well, we have addition, we have multiplication. Which one are we going to do first? We're going to do our multiplication first. Multiply and division first. So 4 times 3, 14 plus 12. And then we can finish that addition. 14 plus 12 is 26. So there's the answer to our PEMDAS problem. How about this guy? 6 times 4 divided by 12 plus 72 divided by 8 minus 9. Oh my word, so much there. No parentheses, which is nice. But our first step, remember, is multiply and divide, going from left to right, whichever one comes up first. So looking left to right in this problem, the first multiplication problem that we find, or division problem, is this 6 times 4 right here. So we're going to do that first. 6 times 4 is 24. Copy down the rest of your problem, plus 12, or divided by 12 plus 72, divided by 8 minus 9. Okay, are we done with our MD? No, we still have division problems in here that we need to do. So again, going left to right, which division problem do we run into first? And it's this one right here, 24 divided by 12. 24 divided by 12 is 2. We'll write that down. Plus 72 divided by 8 minus 9. Keep copying your stuff down as you go. Okay, next of our division problems is 72 divided by 8. So 72 divided by 8 will give us 9. So again, copy down the rest of your problem. 2 plus, now we've got 9 minus 9. Okay, we finished up all of our multiplication and division. Now we just have a bunch of addition and subtraction that we need to take care of. So we have 2 plus 9 minus 9. Which problem do we do first? Do we do the 2 plus 9 or do we do the 9 minus 9 first? We do the 2 plus 9 first because we're always going left to right, whichever problem shows up first. So 2 plus 9 is 11 minus 9, and 11 minus 9 is 2. So that's our final answer for that problem. So hopefully this will give you a nice start for working on your homework. As I've said before, I don't care if you use a calculator. I can't stop you, but I do strongly recommend at least trying some of this on your own, especially the long division and the long multiplication, and particularly the long division because you need to have a remainder as your answer instead of a decimal because we are dealing with whole numbers right now. If you have any questions about any of the topics on here, if you're having any problems or concerns, as always, feel free to drop by office hours. I would love to see you there. And thank you for stopping by to listen.